Hi everyone. So I wanted to go over a little bit of the basics of game development in like, I don't know, 45 minutes. I hope it'll be 45 minutes, but there's a lot around game development. It's a very big topic, and I obviously cannot teach you everything. Sorry, I'm just gonna move my microphone so you won't see it in the frame. But yeah, also this will not be edited, and I'm sorry in advance, but I just don't have time. But yeah, so I wanted to go over sort of the basic of what game development is, how to get into game development, basic of game code, not so much like, I'm not going to teach you C# or Python or C++ in like half an hour. That's not going to happen. But basically, what are you going to look code-wise when you're writing for games? So this is a very, very condensed lecture that is like based on 4 different lectures. And even that, it's like mix and match. So keep in mind, it's going to be like very condensed and but sort of give you an idea of how to approach game development. Okay, so question when we talk about game development is, what is a game? What makes something a game versus any other forms of software, I would say, since you're doing some hackathon. So there's a lot of different way of like saying what is a game, and none of them are wrong, but none of them are precisely correct. Some will be for example, Katie Sella and Eric Zimmerman has a very good intro books, and they see as games a system in which players engage in artificial conflicts defined by rules that result in quantifiable outcome. And that is right for a lot of games, but not all games have quantified outcomes, for example. Another definition is a game as an end and a mean, an objective, an outcome, and a set of rules to get there. Again, not every game has a set outcome. Some games, I mean, like Dwarf Fortress. I don't know if anyone played Dwarf Fortress, but Dwarf Fortress doesn't have a quantified outcome. Even Minecraft, if you play the alpha version, doesn't necessarily have an outcome or a goal to strive to. Another definition, form of art which participant term player make decision in order to manage resource through game token and the pursuit of a goal. That fits very specific type of games. Again, goals, not all games have token, not all games have resources, all those kind of stuff. Another one, game is a voluntary effort to overcome unnecessary obstacle, which is probably my favorite one, basically because games are, I'll talk about it in a second, are inefficient. And this one that I find the most the best like definition, and this is by Ian Schreiber, which is play activity with rules that involve conflict. Okay, so there's a lot of games, a lot of our games. What are games? Games are an activity. They have rules. They have conflict. They have systems. They have goals. Again, not all of them. All of this doesn't really fit all games, for the record. They involve decision making. That's very almost always. They're artificial AI. They create an artificial world, and they create an artificial experience. Games involve no material gain on the part of the player. This is sort of correct, but not so much anymore. Doesn't fit stuff like casino games, for example, or even esport. But generally, most games don't like don't have any specific material. You play games to have fun. You don't play games to make money, in theory. Games are voluntary. Again, this is not a thing that anyone is forcing you to do. You play games because you want to. Games are representation or simulation of something real, but they are themselves a make-believe. And games are inefficient. And this is my favorite definition, where games will do the most inefficient way to solve a problem. And this is pretty much one of the things you'll see in a game. They'll put obstacle for you instead of going from waking up. I'll take Breath of the Wild. You wake up, you're Link, you go, you fight the boss, any RPG for that matter. You fight the boss, that's it. But no, you have to go all the way around, get some weapons, have the weapon stuff, have puzzles and stuff like that in order to eventually become strong enough to fight the last boss. So a few vocabularies that appears in games, and if any of you decide to do a game, this is stuff that you might hear as you go along. Feature list, a list that details key features or selling point of the game. That would be like, you can have different avatars, or you can climb mountains and stuff like that. Brainstorming, a process to generate ideas. Prototype. A prototype is a playable early version of the game, and I'll talk about the process of making games anyway. Balance, a term used to describe the state of the game system. Most games are not balanced, and a lot of the time when you make games, you always have to rebalance the game constantly. Mechanics are the rules of the game. That's a word you'll hear a lot. Dynamic result when rules are put into motion. So competitive is a dynamic, stuff like that. System, a collection of game mechanics. Most games are systematic in some form or another. Some games are more systematic, some games are less systematic. Like a heavy narrative game might not be heavily systematic, while something like RTS, if I go really old, is extremely systematic. So depends on the game, but they all have systems of rules in them of some form or another. Avatar, direct representation of the player in the game. Playtesting, the systematic testing of gameplay, system balance, and interface to find all the errors, inconsistencies, or issues and report them to the design team. Those are fairly, if you are deciding to make game, playtesting is going to be an essential part of the process. Platform, I'll just explain for a second. The reason why you playtest a lot is because there's no indication always whether the game will be fun, and so a lot of time you have to play test to see if your game works. Okay. Platform, the console, device, or system on which the game will be played. If you're gonna do a game for a hackathon, choose one platform. I mean, generally, if you want to design a game, develop a game, choose one platform. Don't have a lot of them because you're never going to finish. Pitch, a brief elevator speech given to the game publisher or VC. Stuff you might not have to deal with at this point, but again, similar to any system, any computer, software engineer stuff, you have to sell your thing, you have to pitch it. Design document. So this is an important part of the development in general. Game development is very documentation heavy. The reason for this is it takes a really long time to actually make a game. Like, you can make a game in a weekend, but if you want to do a final release game to release it, the average time of most games you play, the average development time is between 2 to 4 years. Some games take 6 years or so. And generally, this is not an individual work. There are solo devs, but they're very rare. And it's very hard to make a living as a solo dev. Most companies will have, let's say, small indies will have between 5 people to 10 people. Mobile will have like 50 to a few hundred, and then like AAA will have hundreds to a few to thousand. So something like Last of Us 2 had 1,200 people working on it. So don't expect to make the Last of Us 2 or any of those games. And again, solo devs exist. It's very uncommon, and it's very hard to make a living as a solo dev. And so design document are basically a document, usually referred to as a GDD, which is a living document. So everyone has access to it, especially the game designers, and they have to update documentation, update the rule, change everything. So it's constantly being updated, and it gives all the information around the game. And you can look online for game design document. The Sims one is very extensive. There's also the Doom one, the original Doom one, which is very interesting. Bugs, error in the game design, code, art, sound, or writing. I'm gonna say on the get-go, your game is gonna be buggy. Games are buggy. I'll get to it in the end, but games are basically a bunch of if statements, and so they're super buggy. And so even like the biggest games that have the most money and stuff like that will still have bugs. Okay, I've never played a game that didn't have any bug. I can think of only one game I only encountered a bug, which was Journey. And that was, I still encountered a bug in that game. Engine, the core program that runs the game. I'll talk about engine in a few minutes. Alpha, the milestone in which all systems have been implemented and all code is theoretically complete. The beta, the milestone at which all systems in contact are in the game. Gold, the final version of the game is then released. So gold is important when you release a game, like as a company. Before you can release it, to any platform, you have to reach gold. And any platform you release will have a different rules of how you reach gold. So one of the things that's happened the last year with, for example, Cyberpunk 2077 is that they reached gold in PlayStation somehow, even though they were super buggy and wasn't running. And so that's a big thing because nobody's quite certain how they reached gold. So reaching gold is really hard. Obviously some places have less as to reach gold. For example, like Steam doesn't care that much today, but like most platforms you might want to release will have gold, and they will have specific parameters in order to reach gold. Milestone, a point at which the developer is expected to deliver some type of predetermined content. Game Jam. You did a hackathon, and game jams are very similar to hackathon. If you happen to have been see maybe that 2 weeks ago we had Global Game Jam, and York was participating, and there's also Toronto Game Jam. But a game jam is a weekend where you make a game. Not always a weekend. Sometimes if you go to itch.io, for example, which is a website where you have game, they will have like game jams that are month long and stuff like that. But the traditional game jam is about a weekend. And that's a good way of like practicing. Game beats, the informal name given to pieces and parts that ship with the game. Depends on your game, but if it's digital, obviously it's every object you have in the game. If it's tabletop, it would be any like dice and stuff like that. And then you have card game, board game, tile game, and dice game. I don't have to say too much. So how do you develop game? How do you approach even this process? So the first thing is, I mentioned earlier, games are not for individual. There's very few people who are really good solo dev because it requires very different skills from their very different skills, very different forms of media, and not it requires someone who's a well-rounded programmer, artist, musician in the most like basic form, and can also make sure that they do work on time. And because also process and how long it takes, you really need a team to do that. So you will need like in the most basic form, if you're making a game in a game jam or something like that, you will need a game designer. Game designer is the person who makes the rules of the game. Okay, so I mostly do game design, so I sit down and decide what is the rules of my game. I write it down, I document it. Most game designers, their tool of the trade is Excel spreadsheets and Word documents. But that's what a game designer does. Then you have programmers. Programmers take what the game designer set and put it in an engine. Now, sometimes you'll have, the game designer might be the artist or the programmer and stuff like that. But the programmer, if you're just a programmer, your job is not to set the rules. Your job is to take the rules that has been set by someone else and put them in an engine. And obviously, like, you can have your own input, but that's the job. Artist does all the art. Art assets are important. They're not always like the highest priority, but a game that looks and feels good is a really big part of the experience of playing games. You need to have, and sometimes that also is the artist, the UI UX designer. Again, sometimes the artist does both. Technical director or technical artist. So technical artists, a really important part of the development process. So those are artists. I put them as artists who can code. They're not the best programmers. They're not the best artists. But what they do is set the work between the artist and the programmer. So a lot of the work of a technical artist or technical director is rigging, if any of you do 3D modeling, shader work, any graphic programming that needs to be done, any stuff in the design itself. Some cases you'll also have a level designer, which basically they design the level, and they're different than game designers in a sense where they don't set the rules, they set how people interact with the environment of the game. And you will have a producer. And the producer is probably the most important role in game development, because if you look at why project failed, majority of the cases is because of bad production. And if you see why project successful, it's most cases because they had a good producer. The producer job is to make sure everyone is doing their job and the milestones are met, and nobody's stepping on each other's back, and you're hiring the right people and all those stuff. It's a very, very important part of the experience. So some of you do software development are familiar with the iterative process. Any of you might come from art, might not be doing the iterative process so much, but games, unlike, let's say, if you're making films or stuff like that, so if you're a filmmaker, what you do usually is you plan everything in advance, you film, which is the production, and then you take it and edit and do post-production stuff. But that won't work so much in a game, because if you're making a game, let's say you're planning everything and then you make the game and then you release it, you didn't check to see if the game is actually good. And one of the things about games is we don't know if the game is fun until we play test them. So instead of doing it in that particular traditional way that art is made, we use iterative process, which is very common in software as well as UX stuff. So you conceptualize, you prototype, you playtest, you evaluate the playtest result, and you conceptualize again, prototype, playtest, etc. And it goes with a circle. And this circle never ends. Like, games, as long as games are being updated, even if they were released, as long as games are being updated, you will go through this process. Now, it depends on the game. Some games are, self-contained, like smaller indies are self-contained experience. They don't need to do a lot of iteration after they were released, but bigger games will go through the iterative process over and over and over again. Okay, so one of the most important things in game development is the rapid prototyping. What you want to do is make a lot of fast, dirty prototype that might be ugly, might be very buggy, but work, and playtest as soon as you can, and do that again and again and again and again. And each time you improve the prototype, each time the prototype looks better. There's less bugs, the art is there, animation there, but you want to start as soon as you can. Just have some sort of prototype, even though it's not everything you want, even though it doesn't have anything finished, even though it's super buggy and the code is ugly. You want it to run so you can see if your idea is actually worth pursuing. So, rapid is a state of mind. Embrace the possibility of failure. It encourages creative risk-taking. So one of the things I say, if you take one of my game classes, is that your first 10 games are gonna suck. And the next 10 games are gonna be a little bit better. And maybe at game 50, you start feeling like you're a good game designer. This to say, not games you release, but just games you make. And for sure, development cycle, again, more time doesn't mean more quality. Just release, do something, make it work, have it tested, and again. Constraints are really important. You're not gonna make the next I don't know, what are kids playing those days? I usually use Magic the Gathering because I always get a few Magic the Gathering. People trying to do Magic the Gathering. Magic the Gathering, aside from being developed for years, and I'm talking the card game, and the concept is the same, even though it's paper based. There's always iteration, it's always fast, all those kinds of stuff, and it takes years to get to the level where the game feels good. The game is fun enough, even though with all this complexity. Your first games should be simple. Have one mechanic, have one rule that is interesting, and build the game around it. Get a good team. Have a good producer. Make sure you have someone who's like critical but not mean. And develop in parallel. Sorry, this is from an article, and I actually had to clean some of the words, but there's still some of it exists. But you want to like make sure that like everyone is doing, like, you can't just, okay, I'll wait until the code is done to make the art. No, the artist should do their thing, while the programmer should make their thing, while the level designer should make their thing, while the game designer should make their thing, okay? Gather concept art and music to create emotional target. And you want to simulate it in your head, so you might want to pre-prototype the prototype. So when you do in development, so this is an important part. Nobody knows how you made it, and nobody cares. There's a very famous article by Liz England, who I guess until a few weeks ago was a lead designer in Ubisoft Toronto, and she talks about the door problem. And all those stuff where you have like a very small rudimentary object, which is a door in the game, and all the stuff that has to go through in order to have that door, both design wise and all the people run it. And at the end of the article, you have the player and what the player think about the door, and the player didn't even notice the door. And that is the thing. If you're good in what you're doing, the players won't notice what you did or care. They only will notice if it's not good. So you want to build a toy first. Build a thing that works, basically. And if you can get away with it, fake it. Make something that is broken. Get some existing art. Like get existing code. Don't write everything from scratch. It's not gonna happen. Get some code dirty, hack it a bit, make it work even though it's not great. Same with the art. Like if you find something that someone did, and you can use it for now, use it. You're not gonna release the game, so it doesn't really matter. Cut your losses, so kill your darling. You all have great idea that you've been thinking about since you were a kid, and then you start working on the game and you realize it sucks. And a good designer, a good developer will say, okay, this is not working, and will move on. Someone who's unwilling to let go of their ideas will never finish their game. And finishing a game is the hardest thing you can do. They will never finish their game, and their game will not be good. So kill your darling if you can. Having theming will not salvage bad design. If your design is bad, it doesn't matter if your code is extremely polished or your art is beautiful. If the design itself of the game is bad, nobody will care. Nobody will play your game. But aesthetics does matter, and your game should look good. Just like make sure the actual gameplay, the idea in the game is fun, and then like care about the other stuff. Don't try to like clean your code before you check if the game is actually fun. Nobody cares about your great engineering. Look, a few games. So when The Last of Us 2 came out, there was gifs around like a game dev Twitter. There were gifs about the way the rope works, and that's like some amazing feat of engineering in the game. Okay, they got rope physics working. It's amazing. Nobody cared except for a few game developers. That's it. Nobody else cared about it. Nobody will care about your engineering. Does it work? Great. Move on. Complexity is not necessarily fun. Some of the best games, if not the best games out there, are all very simple. Create a sense of ownership to keep them crawling back for more. This is important. You'll get to it eventually. Experimental doesn't mean complex. Build toward a well-defined goal and make it juicy. I won't get into game juice, but game juice is like the animation and the particles and like how it feels when you play it. So loads of prototyping. You can't really reduce the time it takes to design the rule of the game without compromising your goal. Again, the design of the game is essential. You can reduce the time spent playtesting by being efficient about scheduling and designing playtests to give maximum information in minimum playtime. Evaluation. When you evaluate your playtest result, it shouldn't be long. it's just yes and no decision. It's like, does this work? Okay, yes. That this doesn't work? No. Okay, I'm going to scrap this. It should be quick and, like, again, dirty is the right word. Build it as fast as possible. Cut corner. Make it as ugly, as cheap as you can get away with. You can polish it after. Make it work. Minimize what you need to build. Only do what is absolutely necessary to evaluate your game. And make your prototype easy to change. You will find problem in playtesting, so make it easy to adjust on the fly. So I won't get into it so much, but there's all kinds of different I just realized that it hasn't changed the screen, so I also will change you the slides. Okay, so there's different kinds of prototyping. You have paper prototyping, which is usually the early type of prototyping. You have physical prototyping. If you want to get the sense of action, you have the playable prototype, which looks ugly, but it works. You have the art and sound. You have interface, and you have the code and the tech. Yep. Okay. The following are some important things to consider while you prototype an idea to make sure they actually provide an enjoyable experience outside of your mind. Short prototyping. Again, don't take too long. Make it ugly. Prototype should solve problem and answer questions. And some idea only work in your head. Again, kill your darlings. We said that before. Okay, so before I move into like game engine, I just want to talk a little bit about playtesting. Playtesting, again, this is an important part of the iterative process. You want to have people play your game, so they can give you feedback, because the most important thing you want to have in your game is to have the game be fun. And if the game isn't fun, then you lose what you're supposed to do. So playtesting in the iterative design process. So early in your process, explore, discover what you don't know, discover what you want to accomplish. When you have working prototype, refine. Is your game accomplish the player experience goal? How do you improve it? When showing the game to others, pursue. Pursuing in a way that it's like you're not gonna convince people to think your game is good if it's bad, but rather have them in the game feel that the game is good enough for them to want to continue playing the game. Okay, so Tracy Fullerton wrote a book, Game Design Workshop. She's also the head of the USC game program, which is, I think, still considered the best program in the world. But she advises that you should start playtesting and iterating your design from the very moment you begin. Okay, I won't go into it. If you want about conducting a playtesting session, but there is like a rule that helps having some sort of introduction, discussion, and then like having some, after they're done playing, it's really useful to have a discussion about the game experience. Usually you have pre-prepared questions, just so you know how to do that. So the basic of game programming. Okay, so there's a lot of game engines out there. Some of them are great, some of them are not so great. And they all do different stuff, and they all are useful for different stuff. Most important thing is get a game engine. Don't try to code everything from scratch. Don't make your life harder. There's a game engine, it will already do the thing, use it. So some examples: Unreal Engine. Most game engine, by the way, are free to get. Unreal Engine, this is a old AAA game engine, so if you play stuff like Mass Effect, the original one, they were all made in Unreal Engine, and nowadays it's available for indie and smaller developers. It's really, really great for first-person, highly detailed work. It's not great if you want to do anything that is more experimental. It uses either C++ or Blueprint, which is node-based programming. From my understanding, most people just use Blueprint, even in like the big company. And the C++ is really odd, but that's generally all game programming. It's not. It's like the language, but it's a weird form of the language. The other one, which I will actually go over, is Unity. Unity is a very, very common game engine for indie and smaller games. Most mobile games are made in Unity. Most of the games you play that are not big $60 games will be made in Unity, very likely. Though more and more games are made in Unreal, but I usually use Unity. The thing about Unity is that it's really hackable. It doesn't have as good as rendering engine. It's not as good out of the box like Unreal is, but it's really hackable and you can do like really weird experimental work in it. And it uses C#. And then you have stuff like Godot, which is another, it's a fairly newer one, but it uses, I believe, Python. You have GameMaker. GameMaker is, a lot of it is node-based programming, but it's also like only 2D games. It's the only one that you have to pay money for a certain type of release. But some of games you'd be surprised that were made in GameMaker. A lot of platformers are made in GameMaker. You can get really good results in GameMaker. Then you have stuff like I have Lamyard, which is the Amazon one. Renpai, this is the anime girl, which is for mostly like, how's it called? It's mostly for like text adventure, like visual novel. All the like dating sim you play might have been done in Renpai, and that uses Python, I believe. I want to say Python, but I'm not sure. Then you have Twine. Twine is a text adventure engine. It uses like HTML, CSS, and JavaScript. And it's mostly just hyperlinks. It's highly useful. For designing narratives in games. It's used very heavily for narrative games, but it's really useful. You want to have like a story-based game. You want to have text. People use Twine. There's obviously some really good games that are just Twine. It has a bit of a reputation because most of the people who were using it in 2012 were trans women, but that's not a bad thing. But it's really easy to use. It's all hyperlink, and if you're doing something that is heavy on writing, you should be using Twine. Then you have stuff like Construct 2 and stuff like that. I won't get into them. You can look them up. I would recommend, if you are wanting to get into it, GameMaker, Unity, Unreal, Godot. Those are like the 4 that you'll see the most people use, with Twine for more narrative stuff. That would be like the stuff you will see generally. Okay, this is the Unity mainframe. Now, the thing about game engine, game engines in general that I would say in advance is that people who are programmers find them frustrating, and people who are artists find them frustrating. People who find them really useful are people who do 3D modeling and any like technical digital, heavy digital 3D art of some sort. It works very similar to Maya or Blender or any of those programs. It's very much hierarchy based, and I won't get into it. There's a lot of Unity tutorials. So one of the things that works really well with Unity is that there's so much out there about Unity. Same with Unreal. But really the Unity forums or Stack Exchange, the Unity and Stack Exchange forums, they're really good. There's tons of YouTube tutorials, like tons of them. So if you ever want to do a thing in Unity, there's just so much out there, okay? It also has the asset store that has a lot of stuff in it and all those kinds of stuff. And it's really neat, and you should check all those stuff. But this is more or less how the Unity, how it will look. And as you can see, it's very like, well, you can't see, but hopefully they'll run the stuff. Yeah, so as you can see, it's very like, it's very geared for people who are familiar with 3D programs. So technical artists are the people I find that have the most like, are easier for them to adopt into a game engine. If you are a programmer and you're writing for the game engine, usually Unity will have like, you will open the code in usually like usually there's either monodevelop, which is based on the comes built in, or there's the Microsoft one. So keep that in mind. Common terminology you will find when you're building a game in a game engine. You will have game objects. This is all Unity based, but most of it is the same in all game engines. There might be like a few stuff that will be slightly different in naming, but more or less the naming and the concept are all the same, no matter what kind of game programming, not kind of game engine you're using. So game objects are the objects in a Unity scenes. They represent character, props, scenery, cameras, etc. A prefab, again, this might have a different name in different game engine, but a prefab is basically an asset that allows you to store a game object with component and properties. This is used for instancing, meaning when you want to generate the same object over and over and over again. Let's say you have a endless runner and there's an enemy. That would be, instead of putting everything and setting up again and again, you create a prefab, and the code will call that prefab, and just it will know, and you use it as arrays. Component, the functional part of the game object. There could be any number of components, stuff like collider, I'll talk about in a second, tags, shaders, material, animation, whatever needed to have that component working, that game object working. A collider is a type of component that is very, very important. And what it is an invisible shape that is used to handle physical collision for an object. And again, this is you will use basically the way game programming work. You have objects, they will have colliders, and when those colliders collide with something else, something happens. So, spoilers, I don't know, code spoilers. If this collider interacts with this collider, something happens. Okay? That's like 90% of game programming. And it doesn't have to be, the collider doesn't have to be the same shape as the object path. It's mostly like, it knows, mostly that the other object knows where the edges of your collider is. Project in Unity or any other game engine, a project is used to design and develop a game. And the project will have all the files related to the game, such as assets and sync files. An important note about most game engine is they don't store it in the game engine. They have a file system with all those different stuff. And one of the things that is really important is to keep it organized. If you want to make games, you have to be super organized. Project setting, this is all the setting for the project. There'll be graphic, inputs, physics, audio, all those kinds of stuff. Build, when you're, and again, this is the same in every game engine, when you're ready to play your game outside of the game engine, you need to build it, okay? Package, this is specific for Unity. They have an asset store, and you can package certain assets and upload them or download them, and that will have all kinds of stuff. An asset can be animation, an object, or there can be code stuff, all kinds of stuff like that. Sprite is a 2D game object, which is usually an image with a few images, usually in a sprite outclass. There'll be a few images and they will be animated. A sprite atlas, as I said, is a texture composed of several smaller textures, and this will allow you to animate the stuff. Parent, this is a thing, again, if you code, you probably encounter it in some form or another. You have a parent and a child. A parent is an object that controls another object. Usually Unity or Unreal, any other stuff will have a hierarchy window, and there you can drag object to parent other object. And this is very similar again in 3D program. It's not a thing you do in code, it's a thing you have in the hierarchy. A tag, which is a reference point we can assign to one more game object, which help you identify it for scripting purpose. So you might tag something as a player, and then like when you script, going back to scripting, if any object collides with an object that has the tag player, then something happens. Okay, a collision occurs when the physical can detect the collider of two game objects make contact or overlap. When at least one has a rigid body component, which I'll talk in a second, and is in motion. Instantiate, create a clone of the object, usually a prefab. Sorry. Instantiation, again, you'll be instantiating a lot as you go along. Like, it just allows you to create a lot of objects very quickly. Quanturnion. So Quanturnion is again a thing that appears a lot in Unity programming. Nobody exactly understands what it does. Even programmers are not exactly sure what it does. It's just a thing that exists. It has to do with representing rotation as data. When you have something that has to rotate, especially in 3D object, you would have to have quaternions. Again, there's this is like quaternions is like the horror word for any game person. Nobody knows exactly what I do. We know it should be in the code. Okay, particle system, a component that simulates fluid entities such as liquid, clouds, flame, by generating and animating large number of small 2D image, and the small 2D image are called particle. Okay, so very quickly, because this is taking forever, just a little bit about C#. So both Unity and GameMaker use C#, and it's very common to see C# used in games. And this to say, bigger company, AAA company usually use C++. I'm gonna say it in advance. But a smaller company will be using C#. And if you're using this time to just make a game, you'll probably be using Unity, you'll probably be using C#. And so C# object-oriented programming language, I don't want to go over all of that. You all probably should know this better than I am, because I'm an artist. So, in object-oriented programming methodology, a program consists of various objects that interact with each other by means of action. The action that an object may take are called methods. Objects of the same kinds are said to have the same type or are said to be of the same class. Now, there's a lot of basics of code. I don't want to get into the basics of every type of language thing in C#. One thing, we have no time. Another thing, it's not really relevant. A few important notes, and then I'll go over a few specific variables you use in games and the one code thing you use in games a lot. So first of all, the language is case sensitive. Lines terminate with a semicolon. Code is put in code block. Inline comment is to slash, and you have block comments. Again, this is like the most basic rules of writing in C#. It's fairly simple language. If I can learn it, if I can figure it out, you all should be able to figure it out. So common variables you will see specifically in games, there's others obviously, but string, which is a sequence of text characters, int, which is an all number, a float, which is used anytime you need to represent a real number. So for example, running speed of your character will usually be a float. If you have text, it will usually be a string. And Boolean, a bool, which is true or false. Usually it's like, let's say, you might have go back to our tagging. If this collider that has, let's say, the player tag collide with this object that is a door, then there's a boolean that says door open. So if it's colliding it, the door open is true. If it doesn't, then the door open is false. Basic stuff. Another thing you'll see a lot are arrays. You should know what arrays are, but in general for game programming, you'll be using a lot of arrays mostly to instantiate stuff in order to have multiple of the same object, which is, as I said, prefab usually. And so usually they will have a data type and then two square brackets, array name, equal. So, this goes to, I mentioned it before, game programming is mostly if statements. I usually also saw a for loop and while loop, but I think I used for loop once throughout every time I ever programmed in a game. Most game programming, if not all game programming, is just if statements. It's if you do happens this, then this happens. If it happens this, this happens. Sometimes it's an if-else statement. And sometimes they're nested. It's game code is messy. And one of the reasons why it's actually fairly hard to write for games is because you have to anticipate everything that will the player do in the game, which is not gonna happen you just can't. So, and each of them will have to have an if statement of sort. So it's a little bit, as you can imagine, it can get fairly messy very quick. But if statement is used to execute code based on condition, the condition must evaluate to true for the code to execute. It is important to know that most of game programming is based on if and if-else statements. So if true, then you do something. That's the basic of it. And if else, if a certain thing happens, do this, else do this. Okay, this is like 90% of game programming. Colliders, if statement, instantiation, and occasionally a Quanturnion there. That's it. The problem is that there's a lot of it, and you have to anticipate a lot. Okay, so that's it. It took a really long time, but hopefully it helped you a bit, just to understand sort of what you're getting into if you want to make a game. It's a little bit, probably the most important thing if you do want to do a game is be organized, have everything named correctly, make sure everything is correct in the 5 folders, make sure you have a game design document that everyone gets access to but not necessarily writing, make sure the design, you have someone who's producing, make sure you have something, make sure the mechanics and the game and the rules of the game are working before you do before you try to get the code or the art or stuff like that refined. Like you can start making them, but you have to play test and make sure the game is fun before you get to the point where you're cleaning the code, for example. Don't clean the code if your game isn't fun. Okay, so that's it for me. I don't know how they'll put it because stuff, but yeah, and good luck everyone.